Hello everyone, welcome to Sync Session, our second Sync Session. We're going to cover three drills like we did before. The first one for our learning activity 5, this Sync Session we're just going to build out, keep going with getting more practice with Python. We're going to build some little calculator apps. And then after that, in our second Sync Session today, we'll focus on calculating volume of cube, creating a person contact dictionary object. Again, just getting more proficiency with building out little Python programs before we get into the heavier duty stuff. And then on learning activity 7, this is our database integration. This is where we're actually getting into some of the data science as well as data integration. And so we're actually going to be using Pandas core function, and then we're going to create a sample size. First, we're going to use a randomized NumPy data frame. I'm sorry, rather a NumPy data set imported into a data frame, and then we're going to do some correlation analysis on that, a small data set versus a large data set, so you can kind of get a feel for just starting a conversation around sample size and how that impacts your machine learning development process. And model evaluation as well. But next up, we've got create a core plot using this select star from sales.vSalesPerson. So this is an exercise not only to get us into using the core function, but also using and integrating PyODBC. One thing that I did notice that people had posted, and if you hadn't spotted it in the Slack, there is a bug that popped up, and it shows itself in the ODBC driver, the PyODBC.connect driver string. So you can see here, driver equal to SQL Server. This is what it should look like. This is what it looked like in the original video that I had posted was showing this ODBC driver 13. And that actually caused some problems for some people and threw an error. Apparently I have an older driver that's installed on my machine. So most people who downloaded it and did a fresh install, you're probably looking at a newer driver. There's two ways to fix that. You can change this to 17, or you can actually just get rid of all of that together and you can just say driver SQL Server, and that seemed to fix that issue for people. So anyway, that's all we had to do with that. So if you did encounter that, change your driver string there to SQL Server, and that should take care of the rest of that. But this should actually get you all set for your sync session drill. And with that, let's go ahead and go straight into our first sync session, which is going to be back up here. We'll break out into groups and we'll get this going. So we're going to start off on learning activity 5, and then we'll just keep rolling from there.
Or does it have to be something different?
No, I think, yeah, you can. I think what you're doing right there looks totally, yeah, you're good.
Okay. Okay, so inner length of side 5, and we should get an error. Oh, sure. Okay. Case sensitive.
Yeah, that's those cases.
And we still don't like something. Okay. Can't multiply by the string. Okay, so then we need to change. All right, third time's the try.
Nice work. So the other, yeah, actually that's not a bad way to do it. So the other way is because you put a string on the input. That's why it's complaining, but it's okay. I think what you got like this is just fine. So converting the inputs to int, that works too. So yeah, looks good.
Okay, can you remind me how to change the type of the input? Because I ran across that in the other exercises.
So what you can do is change that input 1 to an int before.
Oh.
Yeah, before you, and then that way you only have to, yeah, you can
put it there. Okay, that makes
sense. Yeah, give that a try. We'll have time. Yeah. Yeah, and that's an even cleaner way to do it. So yeah, but the way you had it before would work too. So nice work.
All right, so, okay, perimeter using user input and equation for the perimeter. So very much similar, but our perimeter is then times 4. And okay, and if we do the same, we should get, oh boy. Oh my gosh. I don't think my head's in the game today. All right, there we go.
Nice work. You made short work of that.
Glad I took the first one.
Yeah. Cole, you're jumping out at the right time, right?
Oh no, I forgot about that.
Try to hang on as long as I can, but
No worries, no worries. You know, these are all, we'll of course have these all recorded for you, so we totally understand. So let's see, calculate the area square looks good. Calculate the perimeter of a square, that looks good too. I mean, you guys are like, I figured you take a little bit longer. How much time do we have here? Let's see. What's the breakout room?
it was 20 minutes.
Yeah, 20. Well, I got it done in less than 10.
So I guess on the first one there, you could do like asterisk, right, as the power.
Yes, you could do that too.
And then what would be like the, is there a function, like a POW function also?
Yeah, so you can do an import math.
Import, that's right, okay.
But yeah, you can do import math. And then, so for example, if you put it up there, you can do the import, and then, yeah, the power, you can do a POW function on that. And that works too.
So that would just be input.pow.
It'd be a math.pow.
Math.
Yep.
Pow,
And then
okay.
input comma 2.
Okay.
Yep, like that. That's another alternative. Yep.
Okay.
Yeah. And let's see. So there's definitely a lot of different ways to do that. But the math function, that gives you a lot of capability to access other math capabilities too. So square roots and logarithms, and you can do a lot of stuff just off of that math library.
Okay. That import step was kind of gets me.
Yeah, the library, the import library. Yeah. And we'll actually be using that quite a bit more next week. We're going to be using a lot of the imports, just because you can't, so many of the algorithms for what we're going to be doing for class, they're going to be heavy on the scikit library specifically.
Okay.
Yeah, there you go. Yeah, perfect. Excellent. And then on the bottom one, calculating the perimeter of a square. Yeah, that's really all you've got to do there. There's not much I think that we can do with that, because I mean, yeah, it's about as simple as what you have there. I mean, there's not really any enhancements or adjustments you can make to that. You don't need to use a math function. Yeah. Okay, well, very good. I think what I'll do is I'm going to jump over, and then Cole, maybe you might be able to catch it a bit of the next one. Let me go jump over and see what how the other team's doing, and then might be able to break this early.
All right.
whatever the executable is, it would open a Python terminal where you could then write that same code, just like you were in the cell above. Mike, do you know? So we aren't able to just run Python in this PowerShell terminal. Do we need a different name for that? Is it called something different, or?
Yeah, you gotta you have to open up a yeah, for some reason this terminal is different from the I don't know why, but you have to open up a command shell notebook, a PowerShell notebook.
Okay.
Yeah, so if you go to file and then if you want to run Python 3 in a command shell, that's the easiest way to do it. Yeah, I'm not sure why the terminal down here should work. I'm not sure why it.
Yeah.
Yeah, because I
still just running on his local machine, right? So.
Mm-hmm.
So yeah, you should be able.
It may just be because the path isn't set up.
Yeah, I think that's what it is. Yeah.
Yeah.
Because it should technically work, but the path for the notebook within, that's why. Yeah.
Yeah.
You'd think. Nice. You guys actually made a function. Okay.
Little extra.
Right. Yeah. Very good.
Why don't you try using that real quick before we stop here? So if you run that cell and then just make a cell below that.
Just run this right here.
Yeah. So all that's going to do is create the function. It's not going to run anything inside the function.
Okay. So I need another code cell.
Yep. And then if you just do perimeter with parentheses and run that.
Okay. Okay. Got it.
Cool. So, we put almost all of our code into functions and sometimes into classes with functions and things like that. But all just in an effort to kind of package up code that does a single task. So then, like here, we can just use
kind of keeping up with the softball and basketball with their kids going through. So that's
The
fun.
Southeast Dynasty continues.
Yeah, they seem to be doing pretty good these days. So fun.
All right, there we go. So yeah, they're wrapped up too. They're actually doing one thing that's actually a nice thing to showcase. And I didn't think to. This is a good idea to put under for exercise number 2 that we can show, which is creating a function. So so let's do this real quick so that you have a feel for this too. It's not required for us to do. It makes life a lot easier. But what we can do is for the creation of a function, what you would do is put a def, DEF on line 1.
Sorry, did you say the area or the perimeter? Oh, you said exercise.
Yeah, go ahead and do it on number 2. Yeah, exercise.
Okay.
Number 2. Yeah, so go up and create a new line above all of it, and say DEF space perimeter, and then put that in parentheses. That put a paren, left paren. Yep, and then to define this is defining a function. And what you can do here is to define the function, you put a colon at the end of that. Yep. And then what you'll do is, let's see, input perimeter, and then down at the bottom when you say print perimeter is perimeter, that's fine. We can leave that because you do a return. I think that'll work. So, but remember with Python, you have to indent your code here. So you have to take lines 3, 4, and 5 and indent them.
I do that all at once?
Yep.
Okay.
Yep. And then, so then that defines a code block for that function called perimeter. Now what you'll do is this is really nice because it gives you a lot of flexibility to compartmentalize code, and you can call this as a procedure now. So if you hit the add sign, so add a code block below it.
Oh,
No, plus sign. Yeah, there you go. Add a code block. Then put in perimeter, and just so now what you can do is just execute that perimeter, and then as a function. Well, you have to put it in, put a parentheses on it. Yeah, then run that.
doesn't like it.
You may not like the name perimeter is not defined. It's
I didn't run the top one.
run the
It,
top one. Oh yeah, then run the
there we go.
Yep. And there it is. So now instead of having to refer to a block of code and rerun it, you've taken all that code and you've condensed it into an object called perimeter that you can call over and over again. So it's kind of cool.
Nice.
So that's kind of a nice little add to it there. Okay, well let me end it for everyone here. Let's see, we're gonna close all rooms. We'll head back to the main room.
And I forget, Troy, have you worked in Python before?
Yeah, I have. It's been a while, so I'm a little rusty, but yeah, I've been doing a lot of JavaScript in the last few years, but I used to do a fair amount of Python.
Cool.
I imagine my question sounded very basic to you three in the last breakout room.
Totally fine. Yeah, it's kind of it's almost awkward sometimes, but we need to it's hard to jump straight into some of this data science stuff and the machine learning because it's easy to forget how much of the just syntax of Python is built into that. So we have to make sure we cover that stuff as well. But so there will definitely be things we're not covering and kind of just throwing everyone into machine learning. So yeah, feel free to ask any questions you have.
Sure, there'll be more.
Yep.
So can you tell me the difference? You said with this, we're running this through a notebook as opposed to Spider being an actual IDE. Is that correct? Okay. So with this, we can't really save the functions as files, like as .py files.
Correct. Yeah. So
Locally?
you can save this as like a Python notebook file and then open it in another tool that can read that file. So like I mentioned last week, like Jupyter is the most common tool for notebooks.
Okay.
It's what I'm using at the moment because I couldn't get Azure Data Studio to work on the Mac, but
Got it.
But yeah, Jupyter, ADS, Google Colab, all kinds of different tools out there that can open those files. But then typically we will, develop the code in a notebook. It's a lot easier to work with and experiment with. And then we'll switch that over to Python modules that we would run through a terminal or something like that when we actually deploy that code. So there's usually a shift there from like the development phase into the production stage. So.
Got it.
Yeah, thanks for showing that, Zach. I showed the other group the function you create using def. Yeah, no, good call. Cool. Well, I guess what do we have next?
All right, number 6. We budgeted 30 minutes for this one as well, so should have plenty of time, I think, for these couple exercises.
Yeah. Do you want to? All right, we'll do 30. See how far we go, and okay, let's do this.
Can you guys see my screen?
Yes.
Yeah, that's good.
Okay. All right, so we're using lists. So calculate the volume of the cube using the following equation. Like time is okay. So first, we probably need to define our list, right?
Yeah, you got a couple of options. Yeah, so yeah, go. That's a good way to start.
Okay. All right, so say L equals except we want to do, sorry. I'll put this into a list, right?
No, I think, well, that's good though. So what you can do is capture it first. Yeah. So capture L, W, and H, and then instantiate the list. And then, yeah, I think keep going. Yeah.
Okay. Okay, I see what we can do. See,
Yeah.
volume.
And yeah, yeah.
So then it would just be my list 0.
Ah, very good.
Let's see if that runs.
Yeah. Hey. So any enhancements to that, Stephanie? Or how does it, or maybe different ways to approach it? I think this way looks pretty good.
Yes, I concur with that. I guess I don't know about enhancements yet. I guess my question is, the putting it in the list, is that good practice? Or, like, what the practical application of saving your inputs in a list, is that a
So yeah, so you will have to, I would say that it's for the exercise of what we're going to be doing. Yes, you will have to a lot of times. So for example, because we're using SQL Server data, we'll have to take the select statements that we create from our database. Now that you've got it integrated, one of the things that you'll find is that for Python to be able to access the data, we'll have to take the SQL output and it'll come across as either a NumPy array or a list. And so it just depends on the situation. So the input will get dumped into, and here's the thing, you won't be able to, like, let's say you had a list of, 1 billion records. Like, we're not working with that much data, but it's still a lot. If you have 30,000 elements in a list, you can't display it here, right? But you need it to be in a list format or an array format, a NumPy array, or a list, or sometimes a dictionary. It has to be in some kind of data set format. And the only way to do that reasonably is for you to take the select star output. And in our case, we'll dump it to a data frame or a list or something like that. But the output, let's say in this case, dumps to a list, and it'll just be a variable object like this. Not always, but like, so for example, you would say like SQL list, it would dump to a SQL list object, and we would just skip this my list equal to, right? We would just take the SQL output, dump it to my list, and then we would iterate on my list. So this is kind of just showing that, yeah, sometimes you do have to do it but I think for the purposes of this, I would say, like, if you were building an application, like a front-end application, you wouldn't be doing it like this though. So your intuition's right, because if you were building an application, it'd be like, why do we save it like that, right?
yeah.
We'll bypass it and go to another one. But the other thing too, capturing the list output from the calculations, that's another, that actually would be a more appropriate use. So for example, you take the inputs and you take those inputs in say V equal to LWH. And then you would say on output, capture VLWH as like a log. So that's kind of off. So for example, if you're creating an application and it's a calculator, but let's say it's a calculator for a mortgage application, you want to save the calculations each time in a log, because if it comes back to bite you from an audit perspective, like someone says, hey, I want to challenge the way my rate was calculated, right? And then you have a log of, well, for your application, this is how it was. Kind of saves you, especially in areas where auditing is, you need a lot of logging going on. Or you can just do what some companies do, which is we don't have that. We don't have that information.
It's lost to the ether.
That's right.
Well, okay, so an enhancement then, if working with 3 variables can code that out. I guess, let's see, how would you multiply it out by all of it? Like, can you, for everything in the list, if you didn't know how many items were in the list, but you
Right.
you wanted to add them together, maybe not multiply, but
Yep. You would do a for loop. You would do a control flow. You would wrap this in a for loop. So you're exactly right. So if where this would be useful, because you do have it kind of, you would say for I in these particular variables. I don't know if we can try it.
So like,
we'd have to create a list of, let's see, we'd have to create an array. So you'd have to make it, so do a bracket to, we'd have to make it up here. So you have to create another input array. That's what we'd have to do.
could you not just iterate through my list?
You can, but you need to have what Stephanie's talking about is like, if I had multiple, let's say I had multiple people submitting a calculation. And so,
Okay.
we'd have to create I'm assuming that's correct, right, Stephanie? Like you'd have like doing multiple calculations, like in a, if is that what I mean? Or is that what you mean?
yeah, I guess, maybe not so much in like, we're trying to calculate the volume, but I guess I'm just thinking if you're taking in things that are creating a list, and you wouldn't know how many were in it, could you add them all up?
That's
so
right.
If everybody's adding in, hey, how many things did I sell or are left in inventory? And so then you want to find out, okay, I don't know if 10 people or 15 people are submitting a number, but I want to add them all together to find out how many widgets are floating around.
Mm-hmm. Mm-hmm. Yeah.
This is a terrible example.
No, that's right. So what we'd have to do is we'd actually have to create a we can do it a couple different ways, of course, but what you would do, just as an example here, like let's keep it simple. So let's say for I in my list, like you've got it here. And then let's just get a variable to print, and then you can kind of see what happens. You might want to do this on another line though, just to kind of.
I'm so sorry, Cole. I'm not even the one like
good.
typing in, and I'm suggesting these things.
Yeah, give it a plus. Give it a plus sign. Add another code block. Code.
Oh, okay. I see.
Yeah. Then what you can do, so let's create a list first. Let's just whatever you want to call it. Yeah, my list equal to, and then in brackets do 1, 2, 3. Yeah. And so this is the way you do a for I in list 2. And then colon, yep, and then you say print I. Let's just get the for loop working. And then run that. So what that does is it creates 1, 2, 3. Now let's do another list, but then above that, you see those 1, 2, 3. Put one in the list. up there. No, sorry, in list 2 on line 1. Put
Oh,
1 in brackets. And put 2 in brackets. And 3 in brackets. Okay. Now, what I want you to do where it says 1, put 1 comma 2 in that. And then 2 comma 3, 3 comma 4. And then run it again. See, now what happens is it's now, so this is kind of what you're going for, Stephanie, because now that list now let's go ahead and go for it. Let's put in, since we have LWH, let's put in 1 comma 2 comma 3 in the list. Yeah. Let's see what it looks like. Oh, no. No.
oh, I keep getting it outside the.
Yeah. And then get rid of that comma. And then here's 2 comma 3 comma 4. So to get the data sets all lined up, 3 comma 4 comma 5. There you go. Now rerun that. So now those are the values. Let's say this is customer 1. Let's say it's student 1 who submitted the first calculation, and then it's student 2 that submitted the second calculation, and student 3. So then now what we can do is make it real programmatic. And then now, because we have I, so what would you build in the for loop to calculate the volume for each one of those automatically? So we'd say V equal to, yep, you got it.
Oh yeah, okay. So V equal to.
So now think about I is now a list in and of itself, right?
Yeah.
So I is a list.
Is that right?
Close. You don't have to list 2. List 2 has been read into I as individual.
Oh, that's right. Okay.
Yeah. So now you can access, but you can access I on each iteration. Right. Exactly. Yep. Yeah, that's right. That's right. Two.
Oops.
And then print V. Yep. And then run it again. Check that out. So now that is doing the calculation on each record of the list. So I put we nested a list of variables, or let me rephrase it. We created a multi-dimensional array. And in this case, this list has a list within lists, right? Because each time I passes one time through the loop, it goes to the next one, and then the next one, and then it performs a calculation on it. So this is how you would build it if you wanted to process like lots of data, right? So yeah. And I have no idea if that's even what Stephanie was looking for. It was just kind of what popped into my mind. Sorry, guys.
We learned something regardless, though. We learned something.
No, this is good. I mean, combining the things, that's, I'm not very adept at that. And so, yeah, I like seeing the loops in action.
Yeah. It's a different way to think, because in SQL, the tables iterate on themselves. So when you do a select star from a table, it's an enumerated object unto itself. And what I mean by that is it goes and it selects everything and it returns everything that you say. In the programming world, that doesn't happen. So you have to manually, like this thing here, you have to manually create a for loop to iterate on the data set. Whereas in the SQL world, you don't have to do that. There's no iteration. Now there is iteration control within you have for loops, control flow, you have if, else, then, whiles, while loops. You have a full control flow suite within SQL. If you need to iterate on data at a much more granular level, but out of the box, you don't have to do for loops in SQL. So it's just a different mindset, and it does create some confusion for developers. Yeah. Okay. Nice work. Well, we got a little extra. Let's do this next one. Create a person contact dictionary.
All right. So
Done with the math stuff here, creating calculators.
following key pairs.
So
All
in
I
this
can do.
case, yeah, use your, yep, that's right. Yep, you
I was
got
gonna
it.
do.
You don't have to do, oh, yeah, you creating your dictionary first? Yeah, that's fine. Yep.
Okay. We can do. Oh. Sure, there's a better way to do this.
I like it. I was thinking get the input and then do an add or replace. So this is, I think,
I guess
give it a
we'll see.
whirl.
See how it goes. Nope.
Oh, extra comma.
Oh yeah. Right there. Nope. There you go.
You don't want to give us your phone number?
Yeah.
Hey, nice work. Nice work. And this actually is a very good use case for like a function. So you could put a def on the top of this and say like customer contact, right? Customer contact entry or something like that. And actually you'd probably even create a method. Customer contact entry would be a method within a class that would be just like class customer. But we're not, I'm not, there's so much in the Python programming world that it's just, you'll be at it for 10, 15, 20 years and never cover all of it. So
So is that the right structure then? Again,
that is correct. That
Okay.
is correct. Yeah.
okay.
And so, yeah, and then, so this is, def is called a function. So if you put a class on top of the def, then what happens is it becomes a method. So in this case, like for example, if you put a class and then customer, yeah, and then you say customer, and then you have to indent the def, yeah.
Okay. So then this would be like customer contact.
That's right. That's exactly
Okay.
right. So
Is
if
that is that just a way to organize or kind of hierarchically do it? Can you could you run, if you said, like, can you call an entire class to run all the functions in it?
Yep, you could. That's right. So that's right. So all these, and when you, all the functions that you've created, those defs, those functions underlying that class would then be rolled up into customer. So if you wanted to then go another step further, yeah, you could just run customer and then would execute all the class. I'm sorry, all the functions under it. The correct terminology though is methods, so it would run all the methods under it. But and then this gives you object orientation, so that's what this is. So now if you run to access customer contact, you have to go through the class. So right, add another, and then we would say
I have to do an import, or would that just?
No,
Okay.
But you can do that. You can do, we could create custom libraries.
Okay.
We could do that. So if you copied this class over to another Python file, you would do an import from that Python file, and it would actually, your library would be called customer. So you do import customer, and then you would have your own, that would be your own user defined library. Yeah, it would be, yeah. So that's right. Customer, let's see how, and it popped up in the auto. So
Yeah.
yeah. Uh-oh.
Oh, they're not running up here.
Oh. Yeah. Yeah, that should have flown.
There we go.
There it is. Yeah. See, now we have something to show on the other team.
And question on, okay, so when you're defining
Yeah.
the method or the function, because it seemed like we ask it at the end to print, but when we ran it to get it into memory or to, you know, make it available, it didn't up top. So is that normal? Like, how do we?
That is normal. So that's gonna, yeah, that's normal. So you have to so sometimes, so for example, like what you had up above, that flew in that cell 7, you were able to run that. Is that what you mean? Without having to re-execute the one above it? Is that?
Well, okay, so when we ran the the first one, the cell, or the method above it, it did not print out the results, even though that's part of the function. So when you're defining it, you can't see the result. Like, do you have to, you know, call it elsewhere to see it?
You have to call, oh, I see what you're saying. Like, you can't call customer contact directly.
Well, let's see, Cole, will you run that
Yeah.
cell?
So you're saying like when we ran this, like nothing, there was no output to it, even though there was a print here.
Yeah.
And then when we ran this one, that's when we got our print, our actual command. So I think the answer is probably, yeah, you have to have something execute this method inside a customer in order to see the output, right?
Yeah. Yes.
Is that what you're?
Yeah, I think if that's what you're asking, that is correct. Yeah.
Okay.
Yeah. So because when you run this, it's all it's doing is saying the logic, the object is then stored in memory but not executed. Okay. Yeah. So it's not actually executing the program. It's just compiling it and making it available for future use. And so it saves it, and then it makes it available upon calling, but it doesn't execute it. So it saves it, but it doesn't execute it. Yeah.
Okay.
Now, just for online too, just because we're recording this, in case, just to annotate, would you mind annotating that next to it, just saying this is a customer class, and then under that, this is a customer contact method. Yeah. Yeah, just so people people are interested. Now, what's cool is you can copy this. So from an application perspective, if you said, okay, and this is object-oriented programming 101. So this is kind of outside of what we're trying to do for this, but that's okay. We got extra time. Let's do it. If we create a customer class, typically you would create like 3 methods or 4 methods under it. You would say customer contact, you would label that customer contact entry, right? And then as an example, we won't build it all out, but like put in like whatever. Yeah, exactly. Now copy that def and copy it down again to line 10, the whole thing. Oh yeah, that's fine. Yeah, that's fine. Yep. And then pre-dent it. Yep. And then you just call this customer contact, let's say update. Right. And then you can just put a print statement under it just to get it to work. So just like a print, just print, this is a blank, just call, yeah, this is a blank method. There you go. Exactly. And so what this does is there's actually a ghost method that to be like, I think it's return 0. I forget what it is. It's some kind of like you return nothing, but this will work too. And then what you'll do is to be totally correct, you would say contact, next would be delete, right? Next would be like let's see, update, delete, and then I think that's it. Enter, update, delete. You might have a return, like in other words, return customer data. So anyway, they call them CRUD, like create, read, update, delete. So CRUD operations. So anyway, this is how you would create a true object-oriented object, class method. And so then this makes it very accessible across all of your code, and also it makes sense, right? So so now if you rerun this whole thing, right? If you do a customer dot contact update, let's say, it won't do, it'll, right? See now, did you see the smart, see now all of those pop up? You have delete, entry, update. Yeah, the customer contact is still in there because it's still in memory. But yeah, exactly. So it'll run, this is that serial flow. So then it's going to run one first, and yeah, and that's great. And then this is a blank method. So there you go. Yeah. So that's kind of, if we were kind of teaching you more of a software development course, we would go all in on object-oriented programming, and we actually teach this as part of our programming 2 courses. So programming 1, programming 2, we get into a lot of this stuff. But yeah, for us here, it's this is a nice to know for you. So okay, I don't know, I think we're pretty much, are we at time? Look at that, we burned up all the time.
I'll probably use this as my exit. So
All right, hey,
all right.
Thanks.
Yep, thank you guys.
Thanks. See ya.
Stephanie, tell Heather hi.
Will do.
All right. Bye.
Hey, Zach, with the, so like the differences in sets and dictionaries, but they both use curly brackets.
Mhm.
So when you create one that's just blank, does it default to one or the other?
Yeah, so you can actually sort of think of them as the same thing, and they behave the same way. So the only difference is, it becomes what we call a dictionary once you're assigning a value to one of those keys.
Okay.
But you can think of like the keys in a dictionary are a set. So meaning, they have to be unique and they're not in any particular order. Kind of the same properties as any other set.
I think you can use, what is it, just the set function to create a set?
Yeah, so you can use, there's a set function as well as like a list function and a dict function. So you can use all those
Okay.
functions just the same as you would use like the different types of brackets as well.
So if you really wanted it to be an empty set, then you could use the set function to create it.
Okay.
And we can actually kind of hack the property of that where they have to be unique. That's probably the most common way. If you have like a list, for example, and you want to remove duplicate values, you can just use the set function or turn it into a set. And since they have to be unique, it'll basically drop all those duplicates. And so that's, you know, a quick way of kind of using sets for a different purpose. So.
Okay.
So what fun, sounds like you guys did some fun stuff on yours too.
Yeah, always.
We not to be outdone, Zach, we went and introduced to classes. We went into class methods, yeah, with our extra time.
Getting into this object oriented here. Nice.
Yeah, that's right. We turned their dictionary into a customer contact method, or rather a customer class with contact entry, contact delete, contact update. We're goofy.
Nice.
Yeah, they did a good job. They were doing a lot of extra credit. Well, cool. Let's see. Cole had to drop off, so it's down to us. So I guess we could just, our last breakout can just be us here doing recording here. So
Sounds good.
All right, Zach. What do we have up next?
Databases. So looks like it sounded like everyone had the database connections working. Let me see actually.
I haven't tried it on my work computer yet.
Oh,
yeah.
It worked at home.
We'll see.
Like this first exercise here, I think, is just using some random data, and then the second one is calling from the database that we've been using. So whoever has that working can do exercise 2. Yeah, I think that's it.
So who's driving?
Volunteers, or should I throw it up there again? Go for it.
Go for it. All right.
Yeah, see that? We good there?
Yep, looks good.
Okay. So the first one, we just need pandas and NumPy. Those are both needed to create that data frame, right?
Yeah, that's right.
P. And then I can copy that down, right? Oh, dang it. So I don't have to type all that out. This is just creating the
copy. You should, yeah, you can
random
copy.
data frame. Okay.
Do you need Seaborn?
Yeah, you'll need Seaborn.
To throw the, okay. How's SEABORN? Is there a common abbreviation for this? Was it SNS? Is there a standard, or does it matter there? Can't remember what we did in the
Yeah, SNS is usually the standard.
standard. Okay. Okay, so with this, I have to call this my data frame.
Mm-hmm.
Okay. So after that, I can just call my,
Yeah, nice.
okay, so that gives me my correlations, and then I pass that into Seaborn. Is that right?
Yeah, that would be correct.
Okay. Since I labeled that as SNS.
So you don't have to copy. You don't have to go yeah. I was gonna say you can just go straight to a heat map if you wanted to.
I call this by heat map.
Mm-hmm.
Okay, and then I pass in my correlation and True. All right. That's the basics that I need.
Yeah,
Okay.
I guess technically you don't even need the annotation, but it won't. You won't know what. You'll just have colors, so that looks good.
Okay.
All right,
So
cool.
that's my
So
heat
now,
map with 10.
so what kind of jumps out to you as you're analyzing this? You're looking at the rows A through F here, and then what kind of, are there any strong correlations that jump out at you?
A and F and A and B are the only things over 0.5 either way, positive or negative. Everything else is relatively
We'll see.
uncorrelated.
What is that? Oh, is that?
C and B there.
What do you think,
Oh,
Zach?
C and F. Yeah.
Yeah, 6-3.
Oh, there you go. Yep.
Yeah, that's the strongest
Yep.
correlation. Negative, but does this randomize every time I run this? So if I run this, will it give me another random?
Give it a shot.
Ooh.
Yep. Okay. Got it. There's a 0.7 there. Okay.
So
A lot of variance in that.
yeah,
Every
so
time I run it.
yeah, that's a strong one. Negative 0.71. So D and yeah. So is that a negative or a positive? So when we say negative, what is that saying? Like as an example between A and C, what is that saying between those two variables?
That's the absences example, right? More absences of class, the lower the grade.
Yeah, right. That's right.
Correlation.
Right.
Okay.
An increase in one is a decrease in the other. Yeah. Yep.
Right.
Yeah. Perfect. Perfect.
And then
Okay.
it wants us to bump it up, right?
Yep.
So that's in size here.
Mm-hmm.
Throw 2 zeros on that. Oh, okay. A lot less variance in there. Everything's pretty close to 0.
Mm-hmm.
No correlation.
Yeah.
So Zach, what's the lesson for everyone?
So yeah, I mean, does this
More data.
intuitively make sense to you? So if we're generating random numbers, there's I don't know how you'd say that, but there's more randomness as we increase that sample size, and a lower likelihood that these two randomly generated variables are going to be correlated in any way. But we can also it's pretty common to set a random seed as well if we want to create reproducible results. So in a lot of machine learning tasks, we're actually doing things that are randomized. So a lot of the time we actually want to make that reproducible, so it's not giving us different results each time. So let me just is it just a seed parameter? Do you know, Mike?
I think that's right. I think it's just random seed, yeah, or random state. Random state, is that
Or
right?
random state, maybe. Let me just check real quick.
But that's yeah. Yeah, random state is usually the seed generator for a lot of, yeah. Random underscore state, I think is, yeah. And the other thing to kind of piggyback off of that is one of the things that we stress all the time is the size of the sample. And this is just a perfect example here that we didn't change the data set we just increased the size. So you notice that the data that's going into it from 0 to 100, we didn't add extra. We didn't say, hey, make more, right? We didn't say, hey, make it to 200. We kept the range of data that would go into each one of those columns. We kept that standard, even though we increased the sample size. But you notice that technically, even at 10 samples, we should have technically had, if you, in theory, right? Everything should have been, if it's in a pure random state, should have been pretty close to 0. But here's the thing, the sample size was so small that we were bound to have some that show correlation. Just because, one, the sample size was so small. So that's why we always talk about, like, a lot of times if you're doing something, you don't want to build a machine learning algorithm that's making decisions off of 10 samples or 30 or 40. Typically, what would you say, Zach, is, I mean, something where, I mean, and of course it depends on the task too, but you can get away with some lower sample sizes. Just depends on what it is you're looking to do. But I mean, from your perspective, Zach, what would you say is kind of, what does that continuum look like?
Yeah, I mean, so, you know, I have to throw disclaimers out as a statistician, but it totally depends on what problem you're trying to solve and what model you're using and what the data looks like. A lot of it will depend on how many features you're using as, you know, to predict the outcome. The more features you're putting into the model, the more samples you need to make it legitimate. But from a pure like stats standpoint, I mean, you know, if you remember from intro stats, like the crossover between a t distribution and being able to use a standard normal distribution is like 30, you know, n equals 30. So you can actually get statistically significant results with pretty low sample sizes. But generally in the machine learning world, we want to be operating at least thousands, if not, you know, many times that. So yeah, typically I don't really feel comfortable building models unless I'm at least, you know, 1,000, 10,000 sample size or something like that. For this reason, exactly.
And like, and there'll be an example you're going to see where, and just to kind of add an extra disclaimer, you'll see next week a training data set that is very small. It's extremely small. And to what Zach was saying is it so much depends on its context, but of what it is you're trying to predict or classify. You can get away with doing quite a bit as long as if you have a simple prediction, then you can get away with simple training data and you don't have to have a huge sample size, right? So there's there's some things where it's like it's like borderline, like, why do I even need to have a machine learning model to help me with some of these things? Because they're so intuitive. But at the same time, when it goes back to scaling, right? In terms of if you're doing what Zach's doing, and you've got to have lots and lots of records, lots of sample data. So, but this is a nice little way to kind of test that, actually, because you can kind of see it right away with a small versus a large data set. And I guess technically, as you up that to 10,000, these should even shrink even a little bit more. They should even get even closer to 0. But yeah, you see how some of them are getting into, I'm seeing even more zeros on the, like 0, 0, 0. I'm seeing 3 zeros in a few spots, 2 and 2 zeros in a few. Yeah. So it's just kind of a neat exercise. These are always fun little programs to build. They can kind of show you the tendency of data. All right.
All good. On to the next one here.
Sounds good.
Okay. Cool plot, same thing. All right. Using a SQL input. So I'll need the connection stuff, right?
Yeah.
Just pull it from here. Okay, so import all my stuff first, which is MP. Is this one abbreviated, or do we usually just go with PYODBC? I did do it there. Okay, so I'll bring in my connection.
We're usually aliasing those in cases where we're going to use it frequently. So usually, PyODBC we're going to use once at the top, and it'll be good to go.
Okay.
Those other ones, we're going to have to type pandas dot something over and over and over. So that's why we alias.
Yeah. Got it. Makes sense. And then I'll pass. Query will be that quotes, right? Select all. Right. The salesperson. Okay. And then I need to pass this query into my data frame, which before was just the random numbers. So now this is, no. Is that correct? Do I need to call this? Query. Anybody, do I need to call this PYODBC to pull?
Then you'll do a
Oh no,
PD.
that's where I was using that.
Yeah, you're using that. So here you'll do a PD dot read SQL. You'll do a
Okay.
read SQL. Yeah, there you go. Yep. And then
Then
you'll
into that.
open paren, and this is where you'll pass the query in from
Pass
this
the query.
connection. Query comma SQL con. Yeah. Underscore con. There you go. Yep.
Okay.
Then from
That's
there, you should be able to, so you can do a test print on that. So do a print DF rather, sorry, just
Okay,
to see.
so that's got my SQL query as that data frame.
Yeah, nice work. Yeah. And so typically, because that's so much data, like, what I'm usually in the habit of doing is like, I'll say like a select top 10 star from sales.v person. So
Okay.
that way but you don't have to do that here. You got it all. That's just more of a
To test it.
kind of a, just kind of a best practice. Cause
Okay.
like if you're like in Zach's world, you're working with billions of records and you do a select star from a table that has 10 billion records on it, you'll be waiting on it a while. So
Gotcha.
It would just crash.
yeah, you probably just do a sample
Yeah.
top 1,000 or something just to get it working, and then kind of open it up afterwards.
Okay.
Ironically, I've been actually most of my work this week has been trying to do exactly that and failing because the data is too big. So
Wow.
I'm trying to create small data sets that we can use, for exploration, just because I can't even look at the actual table.
Wow.
I was going to throw in here. So there are two ways that we can do that. So you could do a select top 10 star. And what you're doing there is you're basically putting that limit inside the SQL query. It's only passing that query to the database, and then it's returning 10 rows, and you can print out, the resulting data frame.
Okay.
The more like common way in Python, if you were to type here, just do df.head with parentheses and go and run that. So so now we're bringing in the entire salesperson table, but head is only printing the top 5 rows here. You can pass in however many rows you want into the head function. There's also a tail where you can look at the bottom, n rows. Yeah, just like that.
Okay.
Now, what you'll notice here, working in this notebook, this is the difference you asked before about whether you need to say print. So if you don't say print on these, it's only going to show you the last thing that you outputted here. So you're only seeing the tail. But you can do print head and print tail and see both if you want.
Got it. Okay.
So, but it's good to know the difference between the two ways of doing this. So the way it's written right now, you're bringing in all the data into Python memory, and then you're only just displaying a piece of it. But like he was saying, if this is the first time you've ever looked at this data, if you potentially have big data that's going to cause a problem with memory, you'll want to put that restriction into the SQL query itself so that you're only bringing in a few rows. And that way you don't crash your machine. So that's the difference between these two.
Got it. Makes sense. Okay.
Another thing too, go ahead and do a df.shape.
Shape?
Yep. And no parentheses on that.
Nope. Okay.
And that will show you
Run that as
the
is.
size of this data frame as well. So we've got 17 rows and 22 columns, I think. So I actually, in all of my code, I wrap these two things into a little function that I use over and over and over that prints out the shape of the data frame and then prints out like the head, the top 5 rows or whatever.
Okay.
So every time I bring in a data frame, I do this little display function just to like get a taste of what that data even looks like, make sure it's working properly. So
Got it.
sorry, you can go ahead.
Much easier there. Yeah, no, thank you. Okay, got the data frame. Now we just need to do make our correlation. And then with that into true. No, I don't need to print anything, right? That should just, okay. That all good? That's sales year to date, and sales last year have the biggest correlation. Nothing really over 0.5 on the negative side. Sales quota and sales last year's the closest.
Yeah. And you know, what's really neat about, which is something I didn't learn until last year, was that you don't have to, that select star, the data frame, well, the core function, the core method within the data frame, that df.core method, is smart enough to know, just even though you're passing select star, it automatically grabs what it can calculate. You don't have to put in the specific columns, which is kind of a nice thing to be aware of, just because it's a big time saver. Yeah, I didn't realize it was that smart. So
Are the rest of these columns like string values? Is that what it's doing?
yeah, it just ignores the string values that it can't. Yeah, exactly. Yeah. Yeah, it's pretty cool. So, because in the past, what I used to have to do was you'd have to type out each column that you wanted to add in for analysis, and Pandas is pretty smart like that. So it's a neat way to do it. But yeah, it looks like there's some soft relationships here, but you know, nothing. Maybe in the behavioral sciences, you could probably, you might be able to get that negative 45 to fly, and that 0.6 to fly. Would you say, Zach, maybe kind of?
Yeah, I mean, all of these could potentially be useful for modeling still. The whole point of machine learning models is that they're going to choose how they can use each of these features to predict the output. So yeah, I mean, for like a correlation analysis, you know, I wouldn't get all that excited about any of these values. You know, the 0.6 is kind of on the edge of what you'd call maybe a correlation, but yeah, I mean, one of the things we'll look for a lot of the time, not always, but a lot of the time when we're building a model, we do want to make sure of the correlations between all of the input variables. And we can run into some issues if we have, two features that are highly correlated within a model. So we'll do this kind of correlation analysis. And something like a 0.6, would draw our attention. We might want to adjust something or mitigate that.
All right.
Cool.
I think that's
Anything else?
all we have for this broadcast day.
Yeah.
Alrighty.
I'll throw an extra credit question in.
Oh, okay.
Does anybody know why Seaborn is abbreviated SNS?
Hmm.
Yeah, I had to look it up. Is anybody a West Wing fan? Here's a random question. I guess so. I'm not a West Wing fan, but I guess Rob Lowe's character is named Seaborn, and his name is Sam Norman Seaborn. And so the writers of the package made a joke, and it just stuck. So now, literally everyone in the industry uses SNS for that.
Oh,
So
wow.
Oh, that's funny.
little
Yeah,
trivia.
because
Good.
I never knew why SNS kind of became the thing, because I was like, why would it be SNS? Should it just be SB or? That's right. Interesting.
You can use whatever you want, but yeah, that's
If you want to be cool, you're going to use SNS.
yeah, exactly. If you want to have the respect from others, yeah.
That's right. Oh, that's cool to know, though. That's great for the backstory. Oh, that's going to turn into a quiz question now. Okay, I like it.
You can see people were watch this recording. Yeah.
No, we'll have to find another one for him, right? That's right. Oh, very cool. Well, actually, no, we keep it in there, right? So people that watch the recording got, there you go, rewarded with a
bonus.
bonus question. Well, very cool. I guess anything else, Zach, for us that
Not from my end.
any questions, I guess, from the group?
I don't think so. Not for me.
All right, very cool. Well, just to give you a quick, because we've got you here and like a couple extra minutes, just to give you a quick readout of next week. One of the first things we'll do is it's going to start to sound like we're getting into the word that comes to mind is like I don't know, Dungeons and Dragons type naming conventions. I don't know. It's going to get weird. It's going to sound magical with the stuff we're going to start talking about. But like, so as an example, we'll be working with first up next week is ordinary least squares. So it sounds like a gaming show almost on that one. Then we'll be working with, I thought we were going to do stochastic gradient descent. See, again, it's sounds kind of interesting. But I don't know, Zach, if what your thought is, but I might have to go to the tried and true principal component analysis, or K-means. Well, I guess we'll figure that part out. But we got it. What's that?
Yeah, we can chat about that.
Yeah. And then, because I know it's like, oh, again with principal component analysis. Then we'll be doing random forest. We'll be doing some decision trees using random forest. Yeah. And I think that's just to get you started. So just as a kind of a primer. So we'll do that, and that'll of course we'll just keep building upon that from there. So
yeah. Sounds good. If all you need to know to sound smart at parties is just use the word stochastic, and nobody actually knows what that means. And
that's right.
That got me through college. So
that's right.
Cool. I'm excited to jump into that stuff.
That'll be cool. All right. Well, if there's any follow-up for Zach or any bugs fixes I need to fix for me, yeah, just hit us up on Slack. But yeah, enjoyed it.
Thank you.
Thank you, guys. Yep.
Bye.
Have a stochastic day.